Okay, so that's the paper right there, Physics 1. Yeah, so we get to question 21. I believe if I was to do 10 million of these papers, I think the ECZ will have nothing to give you. But it needs a lot of attention and reason, otherwise you can doze off or sleep. But again, I cannot be putting dances and songs and into this. Maybe, okay, I'll try to do my best and make these things not to be so bad. But let's go to question 21. An eye uses a lens, okay, to produce an image on the retina. Which order is correct about the type of lens, nature of the image, and size? So, convex is found in our eyes. Nature of the image, it's real and upside down or inverted, and it is small, very small, of course. So, it's diminished. Our answer is A. Number 22, which of the following statements is correct about total internal reflection? My answer was C. When total internal reflection occurs, the angle of incidence is equal to the angle of reflection. That is one of the rules of reflection. Okay, that is one of the rules or laws of reflection. C. 23, three metal bars are known to be brass, iron, and steel. A magnet was used to distinguish among them by placing it close to them. The following diagrams show the number of tacks picked by each metal. So we've got metal 1, metal 2, metal 3. What are the metals in 1, 2, 3? This is brass, this is steel, and this is iron. How do you know? Iron easily becomes a magnet just there and then it goes with the flow. Okay, so it will lift many of them because it's a soft magnetic material. Steel is a hard magnetic material. It doesn't easily become a magnet. But again, after magnetization, it doesn't easily lose its magnetism. So it will take time for it to just pick up this. But once it's completely magnetized, it will remain magnetic for a long period. Brass is not magnetic. Okay, so it doesn't show attraction. So my answer was C. Metal 1 is iron, metal 2 is steel, metal 3 is brass. 24, the following diagram shows two vertical wires passing at 90 degrees. Let me just move this paper. The following diagram shows two vertical wires passing at 90 degrees through a piece of paper. Okay, so a plotting compass, remember a compass has a needle which is magnetic in nature. In which diagram is the direction of the needle of the compass correctly represented? So if these wires are carrying current, understand that a wire carrying current has a magnetic field around it. This one represents a wire going in with an X. This one represents a wire coming out. How do you determine the magnetic field of a single wire? You use the right hand grip. I'll use a pen. Okay, so this wire is going in. I'll hold my pen like this, the right hand grip. So if it's going in, I'll hold like this. These fingers here are representing the direction of the magnetic field. Therefore, it is cyclic, it is circular. So my wire going in, I move my camera, will have a magnetic field of this nature because I'm holding like this. So the thumb points in the direction of the current, and these fingers are pointing in the direction of the magnetic field. So it is like that. So it is clockwise. Okay, it is clockwise. And then the wire coming out, I'll hold my pen like that. The thumb is pointing the direction of current, and these fingers are pointing the direction of the magnetic field. So here, look at this here. The field direction is going to be anti-clockwise because the current is coming out, so the right hand grip is used. So just imagine you're holding the wire inside and then like that. Then the fingers represent direction of the magnetic field, the thumb represents direction of current. So once the wires are like this, then the magnetic fields are going to be like this, and magnetic field lines are always drawn to come from the north and head to the south. So this end is going to be north and this other region is going to be south, and this will affect the magnet or the needle in this way. The arrowhead on the compass represents north pole of this needle because the needle is also a magnet. Then the other end represents south. So you already know by now to say like, pause, attract. Like, pause, repel, and like, pause, attract. So this arrowhead, which is north, will point towards the south because it's an opposite pole to itself, and that will be the orientation of the compass needle, or the plotting compass. When a piece of negatively charged polythene rod, which is a plastic, is touched by a finger, it is discharged. This happens because electrons pass from the rod to the earth through the person. We call that earthing. Okay, this is the answer here. 26. In a circuit, 16 coulombs of charge passes through a point in 4 seconds. What current is passing through this point? You should know this formula. Charge is equals to current times time. You have charge, which is 16, then time, which is 4. So make I your subject. So you have 16 over 4, which is this 16 over 4, which gives you 4.0 amps, which is this one here. Although here they put 4.00. So now the formula, replace the variables, and then do your math. Our answer there is B. 27. A potential difference of 4 volts drives a current of 3 amps through a resistor. How much electrical energy is converted into heat in 10 seconds? You should know this formula here. Electrical work. Electrical work is equal to charge times voltage. Work can also be replaced by energy, because the amount of work done is equal to the amount of energy transferred. If energy is not transferred or converted, then no work will be done. So this is the reason why work is measured in joules and energy is measured in joules. It's just the context from which you are viewing the whole scenario. So W is equal to QV. Then I replace W with E, which is energy, to make it more relevant. So my Q is my charge. Know that charge is equal to IT. So I have time, I have current. So charge is equal to IT. I just say IT because Q is equal to IT. So I'll just do this. Or you can calculate your charge on the side, then place the values there. But this is current times time, which is this current times time, which gives us Q, which is this Q here. Then 4, which is the 4 volts. So this is the V, which is this 4. It gives us 120 joules, which is this answer here, C. The next question there is, the following diagram shows a circuit with a 15 ohm resistor and an unknown resistor. They are in series. You have the voltage, you have the amperage, or the ammeter reading. These are in series. If you want to find the total resistance of these two resistors, you just add. Okay, so the question says, what is the value of R? So let's look at this. Ampere or ammeter reading is 2. One of the resistors is 15 connected in series with the other one, and voltage is 40. So we get to that. Know this formula. Voltage is equals to current times resistance. V is equals to IR. V is 40. Current is 2 times. Since those two resistors are in series, they're just supposed to be added. This is what the total R should be like. So since this one is unknown, you cannot add unless if it was multiplication. They could have interacted, but this is addition. So they remain like this. You cannot add a known and an unknown value. So you multiply these two by both of these on the inside, because this 2 has to multiply the total resistance. So 2 times 15 gives you 30. 2 times R, the unknown, gives you 2R. Then transpose this to the other side. When you transpose the 30, it becomes a minus. You have a 10 there. Then 10 over 2, or let me just say divide by 2 on both sides, which gives you R is equals to 10 over 2, giving you 5 ohms. And our answer comes out as A. Yeah. So you should know, yeah. Number 29, I put my paper a little bit back. Number 29, a circuit was set up as shown in the diagram. The reading on the ammeter, the reading on the voltmeter, V2 was 4 volts. What is the reading on the voltmeter, V1? 6 minus 4. The way in series, this will be taken to be one resistor, but they're together in parallel. But it will be taken to be 1 in relation to this one here. So this resistor is in series with 2 of these because they're together. This voltmeter is reading voltage across both of them, so it's treating them like they're together. So in series, the voltage differs, okay, and current is the same, okay, in series. So here there's a little bit more I can explain, but let me just say the ratio in which the voltage is being shared between these two is equal to the ratio of their total resistances. Okay, so the fact that across two the voltage is 4, it means the other portion of this 6 volts is being utilized by this. If there was no this part here, then the voltage across V2 would have been 6. So my whole point is they are sharing the 6 volts. So if this one is having 4 volts, then the other one should be having 2. They are sharing the voltage because of their arrangement. So our answer there comes out as B. Question 30. A heater is connected to a 240, they had put newtons here, so I was almost getting, you always trust the papers, and if you fail a little bit, you always think it's you who was the problem, but here I think they made an error, but it can still be solved. 240 newtons, which is supposed to be 2 volts, okay, 240 volts main supply. If the heater has a resistance of 10 ohms, how much electricity or electrical energy is supplied to the heater in 120 seconds? So electrical energy again is equals to QV. Q is equals to IT. Okay, IT. Therefore, charge is equals to current times time. So I replace this Q by this because of the previous solution, like here. Okay, this is Q is equals to IT. So even here, I'd replace this here. I move back. So I have my voltage, I have my time, but I needed my current. So I had to calculate for current using this formula here, IR. I have my resistance and I have my my voltage. So voltage, that is 240 over R. I make I my capital. Current comes out as 24. So, oh my gosh, I didn't finish this one. Or maybe, okay, let me just finish it up. I'll be back. It is possible that there was no answer here, so let me just finish it up, then I'll be back. Okay, so my answer was this one here. I just didn't finish punching here. So the answer is 691,200.0 joules. That's the answer right there. So 31. The following diagram shows an electric circuit that can be used to control temperature of a room. This is a light-dependent resistor. When the light becomes brighter, its resistance becomes lower and current passes. This is a thermistor. The higher the temperature, the lower its resistance. So current will pass when this is subjected to high temperature. Current will pass when this is exposed to brighter light. So which conditions will cause the current to flow in the circuit? So you just have to know these electrical components. Temperature high, yes, for this one. Then amount of light in bright light for this guy here, light dependent resistor. Our answer is A. A metal wire of circular cross section has diameter D and length L. The diameter is this one here and the length is that one there, direction of current. Which pairs of changes, if both are carried out, must increase the resistance of the wire? The length should increase, okay, because length affects resistance. Factors which affect the resistance of a material or a wire, length and also diameter. When diameter is decreased, there's a reason why large appliances like maybe refrigerators don't have small power cables like your headphones. Okay, so the answer is C. Apart from increased length increases resistance, decreased diameter increases resistance, also nature of material. So the next question there is, Elena investigates electromagnetic induction. She has a bar of magnet and a coil of wire that is connected to a sensitive ammeter. This is our ammeter. It just has to be sensitive. So when you push this magnet, the ammeter has to be upset or something. So north south coil and coil of wire. Which movement does not cause a reading on the ammeter? Moving, my answer was B. Moving the magnet and the coil to the left at the same time, there won't be any effect. The ammeter will only deflect when either you push the magnet in or push the coil over. Now if you move if you move both to the left, then there won't be cutting, because electricity or current will only be generated when the magnet, or maybe when a wire, cuts through the fields of the magnetic field of the magnet. So the answer there is B. No current will be produced if both are moved to the left at the same speed. You're trying to catch a chicken and you are both of the same speed, you never catch the chicken. You reach the North Pole and back from the other side. 34. The coil of a simple motor lies between the poles of a permanent magnet. Okay. When current is introduced in the coil, it rotates on its axis. Which of the following decreases the frequency of rotation of the coil? Using a lower voltage supply. Okay, lower voltage supply. Of course, voltage is energy required to move a unit electrons from one point to another along a conductor. So if you reduce it, then you reduce the current. So the rotation will also be reduced. The primary coil of a transformer has 200 turns and is connected to an AC power supply of 25 volts. The voltmeter connected across the secondary coil reads 50 volts. So meaning primary voltage is 25, secondary voltage is 50. Primary number of turns is 200. Find the number of turns in the secondary. I use a portion of the transformer equation. Okay, so this is our primary. It's called the primary because that's where power is being supplied from. Electricity is being supplied from, not because of its size. Secondary coil, and that's our iron core or the core of the transformer. So I use this number of turns in the primary, number of turns in the secondary, voltage in the primary, voltage in the secondary. Number of turns in the primary, which is this one here, to be 200. We're looking for number of turns in the secondary. Voltage in the primary, VP, is this 25. Voltage in the secondary, 50, is this 50 here. So when you cross multiply here, final answer comes out as 400, and our answer is 400 turns. That's the number of turns in the secondary coil, 400. 36. The following diagram shows a beam of electrons passing between poles of a magnet in a vacuum. What is the direction of current and magnetic field? Current is always taken to be flowing to the opposite direction of the electrons. So current will be opposite to this arrow here. And then magnetic field is always, or magnetic field lines are always drawn to come from the north to the south. So the arrow should point towards the south. So our answer here is this one. Current flows opposite to electron flow, then magnetic field lines are drawn to face or to point in the south or to the south from the north. Our answer is B. Okay, so you bear with me these pencil marks here. I hope this guy didn't fail, but he was trying hard to think. So 37, an oscilloscope is used to measure potential difference. The trace with no input connected is shown below. So this one is here, one division, this box, that's one division. So there's no input, so there's just a white dot at the center of the screen. This one can be used to measure frequency. It can also be used to measure DC and or AC voltage depending on your connections. This oscilloscope can also be used to measure, heart rate. It makes those waves of the lab. They are ventricular and auricular pumping. Okay, the lab. So the voltage is 1.5 DC. Y gain is set to 0.5 volts per division. One box will be representing 0.5 volts per division, meaning one division, one box. Y gain, this is the Y axis, meaning going up in the Y, this oscilloscope, oscilloscope the CRO, is set in such a way that when a wave is created, one box or one division will be representing this much. So if two boxes are simply covered by the wave, then that will be 1 volt because each one will be 0.5. The time base is set to 0.5 milliseconds per division. Okay, 0.5 milliseconds per division. Per box, this will be the time in milliseconds. Which of the following traces show a supply of 1.5 volts DC? 1.5 DC. Allow me to think a little bit on this one. So for this question, the answer is C, because I was almost putting D, but I realized here there's no X gain input. There's only time and voltage. So for DC, understand that earlier on I said it can measure for DC and AC. So this is DC voltage. So our answer will come out like this. So you have to go through even the other appearances of the waves that the oscilloscope would show if connected to an AC supply. So for DC, the answer would come out like this. The next question is background radiation is that radiation that comes from the surroundings, surrounding the air, the rocks, and even fallout, like remains of ancient weapons from World War I, World War II, and the like, including even stars. 39. During an experiment, you are given a sample of radon-222 with a half-life of 4 years and an original mass of 64. Hope this guy didn't fail this pencil here. Never mind it. Let's focus on my blue pen. How many days will it take for the sample to lose 63 kg? So you can use different methods. I've used the table method where I've got my mass, half-life, initial mass at the beginning when time was 0. After 4 years, another 4 years to make 8, another 4 years to make 12, another 4 years. So each time I add the 4 years, I have the current quantity. So I'm going to have this one. Okay, I'm going to cut it into half to give me 16. After 4 years, I cut this one also into half to give me 8, because half-life is the time taken for an original given sample of a radioactive material to undergo decay halfway. So you're given 64, and they're asking for how long will it take to lose 63. So in other words, they're asking for how long will it take for you to remain with 1 gram, which is this here. It will take you 24 years. Okay, 24 years. So it is D. The answer is D. The last question in this paper, as I say bye to this paper, how many nucleons and neutrons are in uranium-238? Nucleons are these here. There are 238 protons and neutrons, because the mass of an atom is actually the number of the nucleons, the particles that make up the nucleus. So 238 is the number of protons and neutrons together. In this, the number of protons is 92, which is given here. So if you subtract 92 from this number here, whatever will remain will be the number of neutrons. So we say 238 minus 92 gives us 146, and our answer comes out as D. I say bye-bye for this paper. I'll see you in many more papers. Bye for now.